Hello friends, this is Kailash Kondal, PhD Chemistry Kendriya Vidyalaya Pasighar. I am here with the second part of my balancing of chemical equation and writing of chemical equation. Starting with the writing of chemical equation, as this is a skeletal equation, Mg plus O2 will form MgO. As we are seeing here, in the left hand side one magnesium is there, in the right hand side one magnesium is there, so magnesium is already balanced, while in the left hand side two oxygens are there and in the right hand side one oxygen is there. So this is an unbalanced chemical equation. So next part is balanced chemical equations. What are balanced chemical equation, what are unbalanced chemical equations? So balancing of chemical equation involves a law, that is law of conservation of mass, which is given by Antony Lavoisier, which says that mass can neither be created nor be destroyed in a chemical action. That is, the total mass of elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, if we simply say number of atoms on the left hand side should be equal to number of atoms on the right hand side. Hence, we need to balance the skeletal chemical equation. Now, what are unbalanced and balanced chemical equation? Two examples are there. The first example, H2 plus Cl2 gives HCl, that is unbalanced chemical equation, has two hydrogens and two chlorines on the left hand side, and the one hydrogen and one chlorine on the right hand side. You see the diagram, the left hand side is heavy, so atoms are falling on the left hand side. And in the right hand side you can see, the right hand side diagram, you can see two hydrogen atoms, two Cl2 are on the left hand side, while two hydrogen and two chlorine atoms are on the right hand side, so this equation is balanced. Now let us try to balance the chemical equation by a method. The name of method is heat and trial method. Let's take an example, that is Fe plus H2O will form Fe3O4 plus H2. Now there are various steps, starting with step number 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes by balancing the equation. This method is very good in balancing of chemical equations. Simple chemical equations can be balanced very easily. So first step is to draw a boxes around each formula, in the right hand side, in the left hand side, as given the diagram. You can see. The next step, we have to list the number of atoms of different elements present in the unbalanced chemical equation. As you can see in the table, first column is for element, as the three elements Fe, hydrogen and oxygen are presented here. The second column, number of atoms in the reactants, at the left hand side, one Fe is there, two hydrogens are there, one oxygen is there. In third column, number of atoms in the product, that is on right hand side, 3 Fe are there, 2 hydrogens and 4 oxygens are there. In step number 3, it is often convenient to start balancing with it. Then you have to see which atom is having maximum number of atom, or which element is having maximum number of atom in the equation. You can start with the right hand side or left hand side. It's a simple way. As you can see in the reaction or in the table, oxygen is having 4 atoms on the right hand side, so start balancing with the oxygen. And how to balance? To balance the oxygen atom, as you can see, initially one hydrogen atom, that is in H2O, and the products Fe3O4 hydrogen atom. To balance the, you have, what we are doing here, you are making each and every atom same on the both sides. As you can see, oxygen is 4 on the right hand side and the left hand side it is 1. Then two ways, if you make 4 to 1 or 1 to 4, as Thinking of 1 to 4 is easy, and simply multiply by 4 on the left hand side, it will become 4. To equalize the number of atoms, it must be remembered that we cannot alter the formula, as we are not going to alter the formula inside the box. So you can simply multiply. For example, to balance the oxygen atoms, we can put coefficient 4 as 4H2O and not H2O4. So coefficient should be written before the formula. So this balances the oxygen atom. This is partly balanced equation. Now the next part, we are balancing hydrogen atoms. As you can see in the left hand side, 4 into 2, 8 hydrogen atoms are there. In the right hand side, 2 hydrogen atoms are there. Now we are converting 2 hydrogen into 8 hydrogen, then multiplying the right hand side hydrogen with the 4, then it will form 4 hydrogen atoms, 8 hydrogen atoms. So oxygen and hydrogen are balanced. Now it's a turn of Fe. You can see in the right hand side 3 Fe are there, in the left hand side 1 Fe is there. So you can simply multiply Fe on the left hand side with the 3, and the equation will become a balance. Now step 6. Finally, to check the correctness of balanced chemical equation, we count each and every atom on the both sides of the equation. As you can see here, each and every atom on the left hand side and right hand side are same. The number of atoms of elements on the both sides are equal. This equation is now balanced. This method of balancing of chemical equation is called hidden trial method, as we make trials to balance the equation by using some smallest whole number coefficient. Next step is to write the symbol of physical states. Either your reactant or product is in solid state, liquid state, gaseous state, and sometimes we write aqueous state. Aqueous for the solutions that are dissolved in water. Like the equation is given here, Fe solid, H2O. It is in gaseous form, means it is taken in vapor state. Then Fe3O4, it is formed solid state, and hydrogen is again gaseous state. You simply write the state in the small brackets in front of the formula. Usually physical states are not included in the chemical equations unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and below the arrow of the reaction. For example, if you mix CO plus 2H, CO2 gaseous form, 2H2 again gaseous, at the pressure 340 atmosphere, it will form CH3OH in the liquid state. And this is a photosynthesis reaction, 6CO2. It's written wrong here. It should be gaseous state plus 6H2O liquid state. In the presence of sunlight and chlorophyll, it will form glucose, C6H12O6 in aqueous state, and oxygen in aqueous state. Now question is, why should a magnesium ribbon be cleaned before burning? This question is very important and it may be coming in the board examination. As all of you have seen magnesium ribbon, it is gray in color, but it is stored some white color deposition of magnesium oxide. That is, oxide will take place, so which prevent its burning from the air. So before burning, it should be rubbed very hardly with the sandpaper, or you can scratch with some knife. So this layer of magnesium oxide should be removed before burning of the magnesium ribbon. When magnesium ribbon is burned, it produces a tremendous amount of heat, energy and light energy. So it should not be seen with the naked eyes for the long time. So question number 2 is write the balanced chemical equation for the following chemical reactions. First one is hydrogen plus chlorine forms hydrogen chloride. As these word equations are given here, so we have to write the simple equation by mentioning their states. The first one is H2 plus Cl2 will form 2HCl. This is a balanced chemical equation. Second one is barium chloride plus aluminum sulfate to form barium sulfate plus aluminum chloride. So balanced chemical equation will be 3BaSL2 plus Al2SO4 thrice will form 3BaSO4 plus 2AlCl3. Likewise, sodium plus water, it will form sodium hydroxide plus hydrogen gas. So 2Na plus 2H2O will form 2NaOH plus hydrogen gas. It's a homework. Some skeletal equations are given there. You have to balance the skeletal chemical equations. First one is CH4 plus O2 will form CO2 plus H2O. Second equation is FeSO4 will form Fe2O3 plus SO2 plus SO3. We have to balance these equations by using heat and trial method. Okay, simply write a balanced chemical equation. No need to write all the steps. Second question is write a balanced chemical equation with the state symbols for the following reactions. As two statements are given there, you have to write first write word equation, then write symbol equation in your notebooks. Okay, this was all about balancing of chemical equations and balanced and unbalanced chemical equations. In the next part of the video, I'm going to discuss the types of chemical reactions. Thank you and have a nice day.